Welcome viewers, in this video we'll see the solved problem based on the DC transient response of RLC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. RLC circuit, DC transient response of RLC circuit, problem number 2. We'll see the statement of the problem. A series RLC circuit with R equal to 300 ohm, L equal to 1 Henry and C equal to 100 into 10 to the power minus 6 farad has a constant voltage of 50 voltage applied to it and T equal to 0. Find the value of current. So series RLC circuit available, RLC values are given. The voltage is applied 50 voltage at T equal to 0. We need to find the current, value of the current. So after t seconds of applying the voltage, we can get the following equation. By using the Kirchhoff's voltage law, we can get the equation of RLC circuit. R and LC are connected in series. So based on the KVL, the applied voltage E equal to voltage drop across resistor, inductor and capacitor. Voltage rise equal to voltage drop. That is the basic of the Kirchhoff's voltage law. So R into I, voltage drop across resistor is R into I, plus inductor is L di by dt plus 1 by C integral I dt equal to E. That is the equation number 1. Our aim is to find the transient current. So first we'll substitute the values. R is 300, L is 1, C is 100 into 10 to the power minus 6 and E is 50 voltage. So after simplification, 300I plus di by dt plus 10 to the power 4. 100 into 10 to the power minus 6 is 10 to the power minus 4. While going to numerator, it becomes 10 to the power 4. I dt, integral I dt equal to 50. We will take this equation number 2. Now we need to take the Laplace transform on both the sides to convert t domain into s domain. Again, after simplification, we need to take inverse Laplace. Again, for that, we need to get the transient current. So, first we will take the Laplace transformation on both the sides of the equation number 1. So, 300 is constant, I is I of s. Laplace transform of I is I of s. Laplace transform of di by dt is s into I of s minus initial current, I 0 plus. Then 10 to the power 4 is constant. Integral I dt, Laplace transform of integral I dt is I of s divided by s. 50 is constant. The Laplace transform of constant is 1 by s. So 50 divided by s. Differentiation means s into I of s. Integral I of s divided by s. We know that the initial current is 0. That is not given in the problem. We assume that the initial current before closing the switch is 0. So based on that, 300 I of s, s into I of s. This term is 0. Plus 10 to the power 4 I of s divided by s equal to 50 by s. I will take the I of s outside. So 300 plus s plus 10 to the power 4 by s equal to 50 by s. I will take this s commonly, LCM. So here s is not available, so 300s. Here also s is not available in the denominator. S into s, s square. Here s is available 10 to the power 4. So this s is cancelled on both the sides. So after cancellation, what we got? I of s of 300s plus s square plus 10 to the power 4 equal to 50. Bring this term in the denominator, that side. So that we'll get I of s. 50 divided by s square plus 300s plus 10 to the power 4. We'll take this equation number 3. So the denominator, this is nothing but a quadratic equation. We need to simplify this so that we can take the inverse Laplace. We cannot take the inverse Laplace of this form. We need to convert into standard form. S square plus 300s plus 10 to the power 4 equal to 0. We will equate this quadratic equation equal to 0. We'll compare with the standard equation. Ax square plus bx plus c equal to 0. This is a standard. Here x is nothing but s. A is nothing but 1. B is 300. C is 10 to the power 4. Now we'll go for the solving this quadratic equation, so that we'll get the two different roots. Now we'll go for solution of this quadratic equation. So we know that the standard formula is S equal to, otherwise x equal to, here we are using S equal to minus b plus or minus b square minus 4ac divided by 2a. So we can get the solution of this quadratic equation by using this formula. So S equal to b is 300 plus or minus b square 300 square minus 4 into a value is 1, c value is 10 to the power 4 divided by 2a. 2 into a is 1. So minus 300 plus or minus square root of 300 square is 90,000 minus 4 into 10 to the power 4, that is 40,000 divided by 2. So 90,000 minus 40,000 is 50,000, square root of 50,000. So minus 300 plus or minus square root of this 50,000 is 223.61 divided by 2. Here plus or minus is there. Based on that, we'll get the two different roots. Now we'll split the roots. Minus 300, now split this 2. Minus 300 divided by 2 plus or minus 223.61 divided by 2. This 2 is splitted. So minus 300 by 2 is minus 150 plus or minus 223.61 divided by 2 is 111.8. Now we can write the two different roots. Minus 150 plus 118.8. Minus 150 minus 118.8. So this value is minus 38.2. This value is minus 261.8. So this is the S2 value. So S equal to minus 38.2. So we'll bring this term this side. S plus 38.2 equal to 0. Similarly, bring this term this side. So S plus 261.8 equal to 0. Right? Now this quadratic equation is written in the another form with the two different roots. This is S equal to. While writing the root, we need to bring this term this side. Similarly this side. So it becomes plus. Right. Now we got this simplified form. So that the equation 3 we can write the equation 3 as 50 divided by s square plus 300s plus 10 to the power 4. This is the equation 3. So this term now can be replaced by these two roots. S plus 38.2 into S plus 261.8. Now we need to go for the partial fraction technique in order to split the term. Then only we can take the inverse Laplace. We can take this inverse Laplace easily. We cannot take the inverse Laplace of this form. So that it is splitted by using the partial fraction technique. So here we introduce k1 divided by S plus 38.2 plus k2 divided by S plus 261.8. So before taking the inverse Laplace, we need to find the value of k1 and k2, right? So this equation is written like this by using the partial fraction technique. Now we'll go for the further simplification. So this equation 50 divided by S plus 38.2 into S plus 261.8 is written as k1 divided by S plus 38.2 plus k2 divided by S plus 261.8. Now we'll take the LCM on this side. We'll take these two terms. Here 38.2 is not available. This term is not available, so it is multiplied. K1 into S plus 261.8. Here 261 available. This term is not available, so it is multiplied. Right? So out of two terms, one term is not available, so it is cross multiplied. So these terms are available on both the sides. So they got cancelled. So after cancellation, what we got? 50 equal to K1 into S plus 261.8 plus K2 S plus 38.2. We'll take this equation number 4. Now our aim is to find the value of K1 and K2. We need to select the S value such that one term got cancelled. For example, if you put S equal to minus 38.2, here plus 38.2 is there. If you put S equal to minus 38.2, this K2 term becomes 0, so that we are able to find K1. Similarly, if you put minus 261.8, this term got cancelled, so that we can find K2. Right? So the S value is selected such a way that one term got cancelled. So first we will substitute minus 38.2 in this equation number 4. So 50 equal to K1 into S value minus 38.2 plus 261.8 plus K2 into minus 38.2 plus 38.2. So this term become 0. This term is 223.6. That is 50 equal to 223.6. So that into K1. K1 equal to 50 divided by 223.6. So that is nothing but 0.2236 K1 value. Similarly, we can find the K2 value. So now we are substituting minus 261.8. So that we can cancel K1 and we can able to find K2. 50 equal to K1 into minus 261.8 plus 261.8 plus K2 into minus 261.8 plus 38.2. So this term become 0. This term is 223.6 minus 223.6. That is 50 equal to minus K2 into 223.6. That is 50 equal to minus 223.6 K2. So K2 equal to 50 divided by 223.6. That value is minus 0.2236. So K1 is plus 0.2236. K2 is minus 0.2236. Now this is the equation what we discussed, partial fraction. Now we can substitute the value of K1 and K2 so that we can go further for inverse Laplace. So K1 is 0.2236. K2 is minus 0.2236. Right. So we can write like this. This 0.2236 available commonly. We can take outside. 1 divided by S plus 38.2 minus, due to this minus here, minus 1 divided by S plus 261.8. Now we can take the inverse Laplace easily. This form, this is a standard form. Based on this, 1 divided by S plus A is e power minus at. Here plus means minus, minus means plus. So this is very similar to 1 divided by S plus A. A is 38.2. Similarly here A is 261.8. So based on that we can write e power minus at, e power minus 38.2 t minus e power minus 261.8. So this is the final equation. Transient current of the RLC series circuit. Right. The final equation. Now we'll go for the maximum value. So it is required to find the maximum value of I of t, transient current. How to get the maximum value? Differentiate di by dt and equate to 0. We'll get the value of t. At this value of t, if di square by dt is negative, then I of t is maximum. So it is based on the maximum minimum theorem. We have to find the di by dt and equate to 0. So that we'll get the t value. That t value is substituted in this di square, so that will give a maximum. Right. So now we'll go for di by dt, that equated to 0, in order to get the time at which the current is maximum. So d by dt of this value. This is the I of t. The constant available outside is 0. So e power minus 38.2 t minus e power minus 261.8 t equal to 0. Now we have to differentiate. While differentiating, this term become available at the front side. E of x is x e of x. Differentiation of e of x is x into e of x. Similarly, here x is 38 point. Based on that, minus 38.2 e power minus 38.2 t minus of minus 261.8 e power minus 261.8 t equal to 0. Right. So differentiation of e of x value is nothing but x e of x. Right. This x will come in the front side based on that it is written. Now we'll go for the further simplification. So minus 38.2 e power minus 38.2, here both are negative, become positive. So bring this term that side, so it become plus, minus become plus. So the both the side we have. Now bring this 38 point in the denominator. Our aim is to find the t value. So this term is brought here and this term is brought in the denominator, that side. This term is brought to this side. So after simplification we got 6.853 equal to e power 223.60, the final equation. Now we need to find this the value of t value. Our aim is to find the t value. So take log on both the side with base e. So log 6.853 base e equal to log e power 223.60 base e. Right. So this the value of this is 1.925. What is this value? Log of e power x is nothing but x log power e. This power will come in the front side. So based on that it is come. Then log e base e, this value is 1. We know that log e base e. We will bring this time in the denominator. So t equal to 1.925 divided by 223.6. By simplification we got 8.6 into 10 to the power minus 3 seconds. So the current will be maximum at the time is 8.6 into 10 to the power minus 3 seconds. At this time the current become maximum. So based on that we can write I of t max is, this is the I of t. In that I of t max is, we have to substitute the t as 8.6 into 10 to the power minus, so that it become I of t max. I of t max equal to the value of I of t at 8.6 into 10 to the power minus 3 second. Now the t value is substituted, 8.6 into 10 to the power 3. Then it is multiplied, then simplified. Finally we got 0.2236 of 0.72. This value, e power this value is 0.72. This value is 0.015. So after subtraction and multiplication we got 0.1378 amperes. So the maximum value of current. After simplification we got 0.137. This is the maximum value of current. So in this video we discussed the solved problem based on the RLC circuit. We framed the equation using KVL. Then we take the Laplace transformation. By quadratic equation we solved. Then we are using partial fraction technique. We splitted the equation. Thereby we calculated K1 and K2. After that we take the inverse Laplace, so that we got the transient current. In order to find the maximum value of current, di by dt is equated to 0, so that we got the time period t value at which the current is maximum. That t value is substituted in the transient current to get the maximum value of current. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.